Hello and welcome to this video from Maidenhead Bridge. In this video we're going to see how to install the Cloud Security Connector for Zscaler on Azure Cloud using Terraform. The Cloud Security Connector for Zscaler provides also site-to-site connectivity via PCPA and Advanced NAT Gateway, that is the functionality of a NAT Gateway in the cloud, and you can replace the NAT Gateway on Azure with the Cloud Connector, and with PCPA you can replace the VPN gateway on Azure Cloud. Then it's three devices in one at the end. And this is the demonstration we are going to do. We are going to start from scratch in a region, and we're going to create a VNET with two subnets and the routes that the connector needs. And after, we are going to deploy a Bastion host, and at the end we're going to deploy the connector, the CSC, Cloud Security Connectors A and B, and high availability, and we are going to show how easy it is to connect to Zscaler in different capabilities, because the connector can aggregate multiple tunnels, 1, 2, 3, or 4, or 8, then because Zscaler has a limit on how much bandwidth per IPsec tunnel, that is 400 Mbps. Then the connector is capable to aggregate multiple tunnels, 1, 2, 4, or 8, and provide a capacity of 400, 800, 1.6 gig, or 3.2 gig to Zscaler. That is more than enough. The connector also has the capacity to act as the NAT gateway. Then this red line shows the traffic that will not go via Zscaler, because by default all traffic goes to Zscaler, but you can implement rules and bypass Zscaler. This is important when you have a site that you need to reach with your own IP. And also the connector provides pre-CPA connectivity. This is for site to site when you want to connect for your private traffic with other sites. This is site to site communication. But in this demonstration we are going to implement the tunnels and the bypass. The pre-CPA we will do in another video. The high availability functionality of the connector is very interesting one. We are going to deploy in availability zones. The connector has the intelligence to manipulate the route table. Then if this connector CSC A is the active one, the route table will show next hop CSC gateway of the connector A. The connector B is monitoring all time the A, and if the A goes down, the B will take the control of the route table and will set up the CSC gateway B on the route table. This is the way that is high availability is managed on the connector. Well, let's go to the installation. We're going to use Terraform, of course. All templates of this demonstration are in our support page. Then if you go to maidenheadbridge.com, documentation and support, select Zscaler, select Microsoft Azure, and here you have all the information, the administration guide, videos. The video will be put here as well. And here all Terraform templates with all the explanation, how to implement, and at the bottom the zip file to download the Terraform template. Then here is my Terraform template. All Terraform templates that we remember, Terraform is all about directories, and then you need to specify a directory for each resource you want to create, or resources you want to create. In this case, this is for the VNET. All our Terraform template has the main, output, and variables. You don't need to touch these files, but here on the Terraform auto TF bar is where you can input your values. For example, the resource group that I need for the VNET, the name for the VNET, the main address space for the VNET, and the subnets. The main address space 1061.16, and here I have subnets 24. This template also will create the internal route table or external route table for the connector, and on the external route table this template will create the route to the internet. Then everything you need to deploy the connector first time is here. Then if I go to the VNET directory and I do Terraform plan, it will show me all the resources they're going to create. And Terraform apply. The route tables, subnets, VNets, and all the stuff. Apply, yes. Okay. It's created the resource group, the VNet, the subnets, the route tables, and associating the route tables, all for you. I will show you in the Azure portal as soon as it finish. Okay. This is the all resources were created. We can check here. If I refresh, I have this resource now on UK South. Route tables. Let's go in this way. The subnets, CSC external and internal is created, and the route table. So route tables here. Location equals. Need to refresh. Okay. Location UK South. I have the two route tables created, and the external route table has default to the internet. Okay, has Nets Hub. This is the route table associated here. In the internal, there is nothing yet. We need to create the route and after to tell the connector to manipulate the route. Very good. First step done. VNet's created. Let's create the Bastion host. The Bastion host has an IP and a security rule that allows to reach the IP from reach the Bastion host from my IP. Now let's take a look. And network's done. Bastion host. Again, the format main output variables you don't need to touch, but you need to come here on Terraform auto TF bars and to put your values. This is the location, resource group. I'm using the same resource group for all, VM name, username, and we're going to place this Bastion host in the subnet internal. And also in the route table, I created a route back to my public IP. And also it creates a security group. It's not shown here, but it creates a security group allowing only SSH from my IP. And finally, I will access the Bastion host using this SSH key. Then let's go to the Bastion directory here, Terraform plan. It's already initially the first command is Terraform init first time after you need to do Terraform plan, but in my case the values are the initialization is already done. Then Terraform apply. And yes. Okay, let me see steps. Create Bastion host, then after create the CSCs. The machine that the Bastion hosts is a Ubuntu machine with the latest version of Ubuntu. In the future, if you're using this and you want to change something on the you can manipulate the image here. Okay, now the host was created. This is the subscription. This is the public IP of the host. Now I need to come here. Let's check on the Azure portal. No, I need to refresh from here on virtual machines, and I will put UK South. I have the Bastion host running. Then I will SSH the Bastion host. Let me edit this and put the IP, new IP. And I have the key all already created here. And save and connect. Good. I am in on my Bastion host. Then first step is done of my setup, VNET and Bastion host. The next is to do the connectors. Okay, I will back to my Terraform. I will close the Bastion host, and this is my Terraform for the connectors. Same variables, main output and auto bars. And here is where you need to put your values. The first you need to set up is your CSC model, which model you want. In my case, I'm going to deploy a CSC version 2. The next is if you want to deploy 1 or high availability, we're going to deploy 2 in high availability. Next, select the deployment choice if you want to deploy an availability zones, availability sets, or no infrastructure at all. In my case, it's availability zones. And you can choose your availability zones here. Availability set is not applicable because I'm using zones. The prefix of the virtual machine, in this case I will call it CSCs, CSC MUX2 ACE zeta, and the template will append 1 and 2. Resource group name, virtual machine size. Here is the virtual machine size recommended for each one. MUX2, MUX4, MUX8 or 1. Storage can be a standard. You can use SSH key or password. I'm using SSH key. If you put SSH key, you need to paste the SSH key here. And finally, the resource of the VNET, group of the VNET, and subnet, where to place the connector. And that's it. Let's go to here and do Terraform plan to check all variables are good. Looks good. And Terraform plan. And I will create all the resources, virtual IPs, private IPs, and all the stuff that I need. This Terraform template is creating interfaces, security group, public IPs, associations, all the stuff you need to for the connectors. Everything is automated here. The same you can do via the marketplace using REM templates, selecting it's the same, exactly the same configuration. Meanwhile, this is ending. Let me configure my SSH. This is the Bastion host IP. Okay, and on my SSH software, I'm using the Bastion host as a sham host. I need to put the public IP here, and also number 2, a new public IP. Okay, let's see how things are going. One is creating, now it's creating the second one. Well, the opposite is creating second person. One I think that is different with the Terraform comparing with the marketplace, the roles. You can create the roles automatically here and assign the roles to the machines. So this is quite important because on the other side you need to do manual. These roles are needed for manipulation of high availability. Okay, now I have all resources created, and this is the virtual machine names, MOX 1 and 2, principal IDs, private IPs of each one. The number 1 is the 1.5, and number 2 is 1.8. Let me check. Number 1.5 and 1.8. Yeah, it's the same than before when I did in advance. And also you have some information about the tunnels. There are 2 tunnels because this is CMOX2 and the bypass. This is the bypasses IPs, right? When you are going to bypass something, you need the connector will use one of these IPs. Then you need to whitelist these IPs. Okay, we are ready to go. Then the next step is to creation of VPN credentials and location of Zscaler console. You are familiar with Zscaler console. This is extremely simple to do. I have the credentials already created and the location, but I will show you how to do it. Just Zscaler console, go to administration, VPN credentials, and create a full qualified domain. Authentication tab, full qualified domain. You need to put the email. Show you full qualified domain. The user ID is like an email. This is not correct. This is correct. I don't know why it's displaying in this way. And the pre-share key. Okay, I have all this already created. When you have this, go to location management, and on the location, well, this is my location, the last location, you can need to associate your VPN credential to the location and put the values for firewall control, all the things you want to configure. Then VPN credential, create a location, and associate the VPN credential to the location. Okay, that's it. Then the next step is to running the initial configuration wizard on the connectors on each one. And I will go to the first one, and I will run the first screen is configuration requires Zscaler console, VPN credentials, blah 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 blah. This is what I showed before, and run the wizard. In my case, my cloud is Zscaler 3. If you want to check your cloud is here. The cloud name, Zscaler 3. Number 1. I will select primary and secondary automatically. Do you want to put the VPN credential? The answer is yes. These are my VPN credentials and my pre-share key. Do you want to display? If you want to show, yes. Now it's testing that the primary, selecting the primary, selecting the secondary, and will ask me to implement the values and reboot. Do you want to implement these values? Yes. Bang. Okay. So it's needed only when you do the first configuration. After the configuration is done, if you change the values, you don't need to reboot. Zscaler 3 automatically, yes. Paste. Yes, and yes. Okay. Meanwhile, I need to wait for the CSCs to reboot. Let's take a look how things looks like here. Now on UK South, I have the Bastion host and the two connectors running. I need to wait a little bit here. Meanwhile, I'm waiting here. I will implement a little script for testing purposes on the Bastion host. Okay. Okay. And also, what I need to do now is on my work diagram, on my route table, I will point all traffic via the connector IP. Okay, first one. Then I need to go to the connector Terraform and select the private IP. Okay. And this is reinitial wizard, routing traffic, next step. Now let me go to route table internal. I have this route that is back to my IP for the access to the Bastion host, and I need to add a route for the traffic outbound. Route name default to internet. Okay, destination type, IP address 0 virtual appliance. Okay, looks good. I will copy this name because I will need this name after for high availability. Okay. And now let's add this route. Okay, this route is going via one of the connectors. Then I need to check now if the connector is back. And let's go to the first connector. Oh, sorry, I forgot to delete something on the connector here. That is the config user data. The config user data is connector is capable to to auto create the credentials. Okay, sorry the mistake, but I will say yes here. And if I do show configuration status, it will show me the values associated. Okay, and let me go to second one. Oh, no, sorry. This is not the sorry. This is the reminder to do the VPN credentials and configuration. Okay. Okay. If we check now, show configuration status, the first thing you need to check on the connector. You will see the general information with the values, the model, and all the stuff. IPs assigned, the options for traffic redirection, the public IPs for the tunnels, and the public IP for the bypasses. And the load balancer information, the connector is up and running. The connector is a quite complex device. In this particular case, if you is a VPN concentrator, is a router, is a firewall, and also is a load balancer. It has the capacity to load balance the traffic among the routers. Then everything looks good. I am connector via London. Everything is fine. Then if I go to my Bastion host, because I created a route, if I do ip.zscaler.com, okay, it's all good. You are accessing via Zscaler. Okay, then the Bastion host for default traffic is via this connector now. Okay, the next is to show the bypass functionality, this red line. Okay, this red line, for example, if I go to my Bastion host, if I do curl ipinfo.io, it show me this IP 147.161, okay, 163, okay, that is part of the Zscaler piece. Okay, here's the Zscaler. Okay, then what we're going to do is to implement bypasses for this destination, and the IP, instead to be Zscaler, should be the local IP of the connector. Then it should be the local IP of the connector, that is this one. Okay. How the bypass is done? In this case, we need to configure this functionality, outbound firewall functionality. Before to do how it works, well, you can paste the rules here, or you can use a bucket as repository to place the files. I'm using a repository, a bucket in AWS, because my environment is multi-cloud, but you can use a bucket on Azure as well. On the Terraform template, there is information about how to create buckets on Azure or SWS, depending where you want. In my case, I'm using a S3. What I need to do now is, because the bucket is secured by source IP, I don't want any coming to my bucket, then I have restriction per source IP. I need to put the source IP of the connector on my restriction list. I need to put these values here. I think with this one will be enough. Then if I go to my S3 bucket here, this bucket is here, I have the files here. This is the file with the rules for bypasses. The file is the same for, in my case, for all connectors in my network. Then, for example, in this case is creating a firewall rule. All rules are groups. You can create a group of rule group and firewall rules inside the group. In my case, is bypass Ubuntu services, and for this source IP, I'm saying going to any destination, bypass Zscaler. This is a bypass for Google API. I said from all my network, when the destination is Google APIs, don't go via Zscaler. Have multiple bypasses, the repositories. There's a lot of traffic you can bypass from Zscaler. You don't need to send via Zscaler because Zscaler is not going to scan it. It also can be Office 365 traffic. In my case, I'm doing repositories, some web traffic for specific servers, and for testing site. Here is the information for IP info. Then I'm going to implement this file in the connector. Then what I need to do is going to autobars, yeah, and I need to add the IPs of both connectors because it's restriction by IP. And number two is, if I did everything okay, should be this IP. Maybe I need to add the bypass as well, depending the model. This is my entire network, all places, all IPs. Then coming back to Terraform, I will do Terraform plan. On the bucket, what I want is to add the IPs and Terraform apply. Okay, yes. Okay, and this is the URL of the object. Copy. Then if I come to the CSC box one, if I paste the URL, oh Lord. Do you want to refresh? Yes. Configure firewall. I will sorry. I will paste the file. Okay, there are two options. One is to put the URL, and the other one is to do in manual. Let me correct this one. Because I need to add probably more IPs here, all of them, my bucket. And let's check first. Let's check first if I am okay or if I need to add more. Because it depends on the version. Let me go to configure outbound firewall rules, URL, put the URL, and refresh. Okay, now error. Then let me add all public IPs. Okay, I'm same for the other. And now let's apply. Okay. Now if I come to this one, Open firewalls. Do you want to change the firewall? No. I want to refresh. Yes. Okay. Now the connector downloaded the file from the bucket and apply the values. I will do the same here. Put in the URL. My problem was I was not adding all public IPs. Then let's put the URL. Copy. And let's put it in here. Do you want to refresh? Yes. Now it's okay. Here the file. And they will do the rules. The rules are created here, and there is no changes here because it's the same file. Well, now if I do the test again with ipinfo.io, instead of Zscaler, the traffic will go local via Microsoft IP. Okay, this is the advantage of this functionality, because you can do very easily bypasses from Zscaler. Then this step is done. One important point, all the connectors you can manage from Ansible or AWS System Manager. In general, we recommend to use AWS System Manager for the management of the connectors. Then when you have this URL set up here with AWS System Manager, you can run a command saying refresh the URL for all my connectors. Then in one shot you will apply policies for all connectors. Next step on the demonstration, we did this configuration. The next one is to do high availability. Very good. Then let's back to the Bastion host. Now I will do another check https ip.maidenheadbridge.com. Okay, this URL was also on the bypass list, and it's showing the local IP instead. That's a Zscaler IP. Then it's going direct. Very good. High availability. High availability is extremely simple to configure. The only thing you need to have in hand is the information of the route, because we are going to manipulate this net hub. Right now, because the CSC A is active, this one, the route is pointing here. But what I'm going to do is to configure high availability in both, and I will turn off the A and put in the B active. Okay. Then let's start with this one. Go to high availability configuration 16. Do you want to active? Yes. The first and the pair do manually. Now it's validating the login and all the stuff, and the environment. It's contacting the API and all the stuff internally. And the first that will ask me is the route name. That is default to the internet. Okay. Route name. Route table is this one. Resource group of the route table overview is this one. Paste. You can add multiple routes. In this case, I have the default route via the connector, because the connector manage everything. I will say no. Computer name of the other connector in the group. And resource group of the VM. Then you can take from the VM the name and the resource group. Now it's contacting the API, all the stuff. And it will ask me if I want to apply. Do you want to apply? I say yes. And that's it. It's all you need to do. Now, with this high availability JSON file, copy it and go to number 2. On number 2, I will go to 16. Do you want to configure high availability? I will say yes. But in this case, instead of manually, I will say JSON. And I will paste the JSON file. Okay, then now it's active in both. Let's take a look first. If I do show configuration status, now high availability is telling me that it's active. The route to Zscaler using NetHub 10.61.1.5 of VM this CSC now is the current one that is active in the route. Then if I go to my internal route, nothing will change. This will be the IP. Okay, and now the rest is information, the routes and the computer name if they are the pair, and the private access private and the public access private IP that is for pre-CPA, that is we will show in a future video. And this is all good. Now if I check number 2 on high availability, is saying me the route to Zscaler using NetHub VM number 1, the other CSC in the pair. Then now let's execute this script, and in this script I put maidenhead.com. Okay, this script, what it's doing is when the pin start stops, it shows you when it is start stop. Then to test high availability now, then we'll do I will shut down the active connector. I will stop this machine. Stop. Okay, takes very long sometimes. Then we need to be patient here. When I'm explaining what I'm doing is I'm shutting down this connector. The route is via this. The route table is via this connector. When this connector is down, the other one will say, okay, there is no more no way to get access to Zscaler via the A. I need to make me active, right? And well, this B will touch the route table and will put the gateway NetHub this IP, and everything will start again. But it takes some time to go down, and it's not always very fast. And here on the connector, we'll see that the pin start stops. Okay, and the route table change to this 2.8. Let me refresh here. Sometimes you need to. Okay, now it's via the connector B, and that's it. It's quite fast. It takes some seconds to the bypass to get active, but is very fast. Now, if I do on the Bastion host, if I do the curl to maidenhead.com, the IP that will show me is this one, 57. That is the bypass IP of this one. Well, all is up and running, and as you can see, it's extremely easy to configure. We had some challenge with the bucket IPs, but despite this, nothing else. It's extremely simple. Put the VPN credentials, everything will go up. Put the URL to the bypass list where it's located, and that's it. And finally, high availability. Configure on the first, copy on the second, and it works. And it works. Then, well, this is the end. Well, the last thing we need to check if we are via Zscaler. And yes, we are via Zscaler via the other connector. Okay, secondary one. Okay, well, thank you very much for your time. This is the end of this video. As you can see, it's extremely simple. And we created a full configuration with Bastion host, VNETs, connector, high availability, bypasses, traffic to Zscaler in very short period of time. Thank you very much for your time. If you want, you can contact me directly to ilarsen@maidenhead.com or contact our sales team or via our website or via support. Thank you very much. Have a good day. Bye.